Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 CBCS ऑनलाइन क्लासेस रो वीडियोस गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोस गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोस रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज आमे गोटे नुआ टॉपिक स्टार्ट करिबा द नेटवर्क थ्योरम्स यार आमे बेसिक इंट्रोडक्शन देखिबा तापरे आमे आइडियल कांस्टेंट वोल्टेज एंड कांस्टेंट करंट सोर्सेस विषय पढ़ा सो फर्स्ट जदि आम नेटवर्क थ्योरम कहवा इन ऑर्डर टू मेक द एनालिटिकल सॉल्यूशन इजी ओके सहज एनालिटिकल सॉल्यूशन पाई वी अप्लाई सर्टेन थ्योरम्स so as to solve the problems of electrical networks and simply the network itself okay so the analysis of the electric and electronic circuits require these network theorems for thorough understanding okay and the network is thoroughly analyzed when all the voltages and all the currents in its different elements are determined okay so there are generally two types of methods for the analysis of the networks okay gote hela direct method a gote hela network reduction method so first ame dekhiba the direct method okay so in order to determine the different voltages and currents in the network no changes are made in the network and this method is used for only simple circuit okay kebala simple circuit pai ame direct method use kariba and the Kirchhoff's laws loop analysis superposition theorem and the reciprocity theorem ए विषय रे हमें डिटेल आपको पढ़िबा are some of the theorems which are used for the analysis of networks in the direct method category okay तापरे एबे second category आछि network reduction method okay so for quick calculations of different voltages and currents in the network the original network is changed into much simpler equivalent circuit okay original network जोड़ा थिबो ताको हमें simplify करिबा into an equivalent circuit and this can be applied to simple as well as complicated circuits okay so यार example जदि देखिबा एटा होची delta or star method then Thevenin's theorem Norton's theorem are some of the theorems which are used for the analysis of networks in network reduction method okay and these theorems are most useful in determining the response that is the current voltage and power of the element in any circuit so ये हला network theorem रो basic introduction एबे आसीबा first ideal constant voltage source okay so देखो प्रथमे हम यदि देखिबा an instrument which provides you the voltage output continuously okay to the load which is connected across it is known as voltage source eta tame janicho and there are two types of voltage sources gote hela dc a gote hela ac mane direct voltage source a gote hela alternating voltage source okay so first jodi dekhiba gote dc voltage source bisare then it is that instrument which supplies the direct voltage output and it is supplied continuously to the load which is connected across it okay so here the polarity of the output voltage remains the same in the dc voltage source okay example hegala jemti voltaic cell then Lec-1 cell Daniell cell dry cell battery and also a dc generator okay so these are some of the examples of dc voltage source so when a dc voltage source is connected across any resistance okay generally it is the load resistance right then the current I which flows in the circuit is shown here in the figure okay this is the current I
Okay, this is the load resistance and this is the DC voltage source along with a key. Okay, suppose यार value है ना हमें नहीं गला voltage रो V, right? So the voltage source here shown in the figure also possess some internal resistance. Suppose याको हमें कहला small r. Okay, so that the current which is flowing through the load resistance RL will be given by the equation I equal to V by RL plus small r. Okay, and here the current I can also be referred to as the load current. Okay, याको हमें load current मध्य कही परिबा. So the terminal voltage is the voltage across the load resistance and it is in fact the voltage drop and is generally given by V minus IR or IRL. Okay, इथरो आमे एटा इक्वेशन टा पाई परिबा, राइट. अच्छा, तापरे एबे देखिबा आमे AC voltage source. So देखो AC voltage source यदि कहबा it is the instrument which supplies the alternating voltage output and it is supplied continuously to the load current which is connected across it. Okay, so here the polarity of the output voltage reverses periodically. এটা তুমি জানিছো alternating current রে তুমি পড়িছো polarity টা reverse way periodically. Okay, in the AC voltage source also here the polarity of the output voltage reverses periodically, right? And some of the examples are AC generator, oscillators, then function generators. Okay, so these are some of the examples of AC voltage source. Okay, so when you connect an AC voltage across the load, suppose it is having an impedance value ZL. Okay, then the current I which is flowing in the circuit is shown here in the figure. Okay, here you can see this is the AC voltage source and ZL is the load impedance. Okay, maybe it a resistance ही पारे किंबा इंडक्टेंस ही पारे किंबा कैपेसिटेंस ही पारे किंबा से गुडार कॉम्बिनेशन भी ही पारे जोटा हमें पाउचु इंपिडेंस रे. ओके, एई जिंस हमें इंपिडेंस विषय रे ऑलरेडी इलेक्ट्रिकल सर्किट रे पढ़ी सारिछु. ओके, सो এই जो करंट आसुची याकु मध्य हमें सिमिलरली बाहर करि परिबा जदि हमें कहला इंटरनल इंपिडेंस ऑफ दिस AC voltage source is ZI. Okay, which is the opposition to the flow of alternating current, then the current flowing through the circuit will be given by I equal to V by ZL plus ZI. Okay, so similarly the terminal voltage across the load impedance will be given by V minus I ZI or simply capital I ZL. ओके, सो आमे देखिला दुई प्रकार वोल्टेज सोर्स गोटे हला DC गोटे हला AC. एबे देखिबा व्हाट इज द कांस्टेंट वोल्टेज सोर्स बा आइडियल कांस्टेंट वोल्टेज सोर्स. सो देखो व्हेन एटा होची डेफिनेशन टा व्हेन the internal resistance or internal impedance of a voltage source is 0, then the voltage source becomes an ideal voltage source. Okay, so in this source the output voltage remains absolutely constant irrespective of the changes in the load current. Load current change हेले भी output voltage absolutely constant रहिबो. Okay, because एठी internal resistance by internal impedance टा 0 अछि. Okay, so the internal voltage drop जेहेतु एटा 0 अछि ना internal resistance टा, so internal voltage drop in the source will be also 0. Okay, so it is difficult actually to realize the ideal voltage source in practice. Practically हमें पूरा पूरी ideal voltage source पाई परिबा नहीं, but however if we are taking smaller values of internal resistance or internal impedance, then it can be considered as close to an ideal voltage source. Okay, गोटे एग्जांपल हमें देखिबा. सपोज हमें गोटे 1.5 वोल्ट रो ड्राई सेल नहीं गला. ओके, हैविंग इंटरनल रेजिस्टेंस ऑफ 0.0025 ohm. Okay, it is shown here in the figure. It is a dry source. Okay, having voltage 1.5 volt, internal resistance small r which is equal to 0.0025 ohm, right? Now when this dry cell is supplying no current, okay, then the voltage V, which is equal to 1.5 volt, that means the output voltage provided by its output terminals will be how much? 1.5 volt also. Okay, now if the load current increases to 100 ampere, তাহলে internal voltage drop ଏବେ କେତେ ହେବ? 100 into 0.0025, that is your current into the internal resistance, that is 0.25 volt. তাহলে voltage drop ଏବେ କେତେ ହେଇଗଲା? 1.5 minus 0.25, which is equal to 1.25 volt. Okay, thus it becomes very clear that the output voltage of 1.5 minus 0.25 volt, that is 1.25 volt, can be considered as constant as compared to the large variation in the load current from 0 to 100 ampere. Okay, so a point here to remember, ଯେମିତି ଆମେ ଉପରେ ଦେଖିଲା, in real life or in real practice there is no ideal or perfect voltage sources, but sources having extremely small or lower values of internal resistance or internal impedance can be taken close to the ideal voltage sources, right? ଏବେ ଦେଖିବା what is an ideal current source. Okay, so देखो, an instrument which provides current to the load which is connected across it is known as current source. এটা ଆମେ ଜାଣିଛୁ। ତାହେଲେ ideal current source କହିଲେ କ'ଣ? It is the one which supplies constant current to the load. Okay, so ideal current source is here represented by the symbol as shown here in the figure. This is the symbol and this is the circuit. Okay, this is the ideal current source and it is connected with the internal impedance Zi and the load impedance which is ZL. Okay, so ଏବେ ideal current source रो जदि आमे definition देखिबा, actually in an ideal current source the internal resistance is equal to infinity, but however an ideal current source is not possible in reality because infinite value रो internal resistance तो आमे पाई परिबा नाही. So the current source which is often used in the laboratories as an ideal current source in parallel with the internal impedance, that is Zi, or internal resistance small r. Okay, so it I am a figure देखला and it is having a very high value actually. Okay, because infinite value रो आमे internal impedance by internal resistance पाई परिबा नहीं. Okay, so a point here to remember, voltage and current sources are the active elements which are used as excitation sources in an electrical circuits. Okay, so current value जदि आमे देखिबा, ये जो figure रे, through the load impedance ZL, its value is IL, which is equal to IZI divided by ZI plus ZL. এটা আসলে load current টা, তাহলে याको आमे लिखि परिबा capital I divided by 1 plus ZL by ZI. Okay, now the current through the load impedance IL will be equal to I. केतेबेले एटा हबो? When ZL value is very less than ZI, माने एई जो denominator रे ए टर्म टा पाखापाखि nearly 0 हिजबो और very small हिजबो. Okay, hence a current source provides a constant current I to the load which is connected across it. Okay, and if the load impedance is taken to be very small as compared to the internal impedance Zi or internal resistance small r of the source. Okay, ताहले ये कि आमे कहि परिबा जे the circuit is providing constant current I to the load. Okay, so this is actually shown in the figure. Okay, एरकु आमे गुटे example रे again बुझिबा जोटा आमे previously voltage source रे देखुतिला. Again let us consider a 1.5 volt battery, okay, or voltage source, and it is having an internal resistance now high value which is 1 mega ohm, right, and let the load resistance vary from 10 to 100 kilo ohm, right. So the current which is supplied by the, it is supplied habo, okay, printing mistake achi. So current supplied by the source now changes from 1.5 by 1.01, that is 1.48 microampere, to 1.5 by 1.1, that is 1.36 microampere. Okay, এটা কেমতি আসিলা? এই যে 1.5 তো obviously this is the वोल्टेज वैल्यू आ 1.01 जो लिखा होची एटा मेगा ओम रे लिखा होची ओके माने याकू आमे ऐड कर देला सो एज टू गेट 1.01 सिमिलरली 1 मेगा ओम को आमे 100 किलो ओम सहित ऐड करले पाइबा 1.1 मेगा ओम राइट अच्छा ताले even when the load resistance increases from 10 to 100 kilo ohm आमे देखिला ता माने 10 times जदि increase भी कर देला load resistance को still then the current रो जदि आमे decrease देखिबा it is decreasing from 1.48 micro ampere to 1.36 micro ampere only okay so only by a fraction of 0.12 micro ampere or barely 8.8%. Okay, hence the source for all the practical purpose can be taken as a constant current source. Okay, here this is again shown in the figure. Okay, जोटा हमें previous figure देखी थिला केवल difference है एठी हमें internal resistance को एबे high value नहीं येचो which is 1 mega ohm. Right. So this is all about the basic introduction of network theorems and the ideal constant voltage and constant current sources. Okay.
Thank you.